Hello everyone. Today I will be presenting on sentiment analysis and emotion detection using NLP techniques. In this presentation, we will explore two academic papers that use advanced machine learning and deep learning techniques to analyze sentiment and emotions in text and images. We will cover their methodologies, justifications, results, and discuss potential improvements. Let's begin. For this presentation, I have selected two research papers that use NLP techniques for sentiment analysis and emotion detection. The first paper, published in Springer, focuses on multimodal emotion recognition using both facial expressions and textual data. The second paper, published in Science Direct, introduces a hybrid deep learning model for sentiment analysis in social media. Both papers provide valuable insights into cutting edge NLP applications. Now, let's dive into the methodologies used in the studies. Sentiment analysis is the process of determining the attitude or emotion behind a piece of text, typically classifying it as positive, neutral, or negative. Emotion detection goes a step further, identifying specific emotions such as happiness, sadness, anger, or surprise. These techniques are crucial in social media analysis, where they help businesses, governments, and researchers understand public opinions and trends. To analyze sentiment and emotions effectively, researchers have explored both text based and image based approaches. We will review two papers, one that applies deep learning to detect emotions from facial expressions, and another that uses NLP techniques for sentiment analysis in text. We will examine their methodologies, results, and discuss possible improvements. The first paper focuses on detecting emotions from facial expressions using deep learning. It employs convolutional neural networks, or CNNs, which are well suited for image analysis. The model is trained on large datasets of facial expressions, allowing it to learn patterns associated with different emotions. Preprocessing steps like grayscale conversion and normalization improve the model's accuracy. CNNs are chosen because they excel at recognizing spatial hierarchies in images. Unlike traditional machine learning models, which require handcrafted feature extraction, CNNs learn patterns automatically. Studies show that CNN-based models significantly outperform older approaches in emotion detection from images. The CNN model achieved high accuracy in identifying emotions from facial expressions, making it suitable for applications like AI-powered customer service, mental health monitoring, and surveillance. However, some misclassification occurred in cases where facial expressions were ambiguous. The second paper focuses on sentiment analysis using natural language processing. It applies machine learning models such as support vector machines or SVMs and recurrent neural networks or RNNs to classify sentiment in text. Preprocessing steps like tokenization and stop word removal ensure that only meaningful words are analyzed. The authors used SVM because it provides robust and interpretable results. RNNs, on the other hand, capture sequential relationships in text, making them effective for sentiment analysis. The paper demonstrates that hybrid models combining both approaches achieve the best accuracy. The results show that the hybrid SVM plus RNN model achieved the highest accuracy compared to using either model alone. It was tested on multiple sentiment datasets and performed consistently well. One major improvement over traditional sentiment analysis models is the use of transformer-based architecture like BERT and Robert A. Unlike RNNs, which process text sequentially, transformers analyze entire sentences at once, capturing context more effectively. These models, pre-trained on massive datasets, significantly enhance accuracy and generalization across domains. A limitation of current research is that text-based sentiment analysis and image-based emotion detection are often treated separately. However, combining both approaches multimodal learning can enhance accuracy. For instance, an AI chatbot can analyze both a user's message and facial expression to determine their mood more precisely. Another improvement is the use of data augmentation techniques. One challenge in sentiment analysis and emotion detection is obtaining large, diverse datasets. Augmentation can artificially expand training data, improving model robustness. For text, we can use techniques like synonym replacement or back translation. For images, applying transformations like flipping or brightness changes enhance diversity. A key challenge is domain adaptation. Many sentiment analysis models work well in English but struggle with other languages. Similarly, models trained on one industry, like finance, may perform poorly in another one, like healthcare. A solution is transfer learning, fine tuning pre trained models on specific models or languages to improve accuracy. One of the biggest concerns in sentiment analysis is bias. Models trained on biased datasets may reinforce stereotypes or misinterpret sentiments, particularly in different cultural contexts. For example, sarcasm detection remains a challenge. Solutions include bias detection tools, ethical AI frameworks, and ensuring diverse, inclusive training data. These techniques are widely used in business intelligence, political analysis, and customer feedback monitoring. However, there are ethical concerns such as algorithmic bias and data privacy, which must be addressed when deploying these models. To conclude, sentiment analysis and emotion detection are evolving fields powered by NLP and deep learning. The two papers we reviewed highlight state-of-the-art methods and areas for improvement. Future research can explore more advanced AI models and multimodal analysis to further enhance accuracy. Thank you for your attention.